Hello, everyone. We're just setting up the stream now, so we'll be starting some prints and some 3D printing stuff in just a little bit. So we just want to make sure everything's just working fine. So hello, I'm Dennis. I'm part of the 3D Potter team, and we're just getting the stream set up for our first time. So just give us just a little bit. Chat. I'm muted here, so we are. Looks like we're good. We're doing good.
Okay, so Dennis is running the computers, and I'm Danny. Our first live stream, so we're going to do a demonstration today. We're going to print something from Potterware, right?
Yeah. We're gonna generate some stuff in Potterware and just making sure your audio's working. Just a moment. We're still just almost set up fully.
So
Yep. You're good. Okay. Yeah.
let's go.
We're gonna open Potterware with our software on our streaming computer. Our streaming computer is in the other room, so we're gonna switch over to there and open Potterware from Emerging Objects, and that we're gonna show a live demonstration of how to generate a pot with one of our printers.
This one?
Sorry about the black screen. We're just getting this running up. Oh, shoot. Not that one. Sorry about that. Okay.
All right, so this is just a simple object we're gonna do. So this is Potterware from Emerging Objects, and the link. I think we have a link in the description.
Mm-hmm.
So we're gonna select our printer here, which is Potterbot 10 Super, and the speeds are set. They work relatively well out of the box. So coming down, layer height is 2.1, object height is 181, and then we can manipulate the size and shape over here. Extremely easy. So let's go down to 80 there. Takes a little while to regenerate. It is on the cloud. All right, the top's too big. And then we're going to come down to horizontal effects. For this demonstration, we're going to hit sine wave and interior wave offset. You have to experiment with this. I'll show you in a minute. The wave repetition, 35 is too much. Let's try 21. You can see in a second what we have. They're not very visible. It will be in a second. The wave amplitude will go up to about 17. And now you can start to see what we're doing. Okay, and we're going to make bumps and waves. So we're going to do wave cycles 2. And then the spacing between the cycles, we're going to do 5. And let's see what that looks like. And there you go. Now the offset is quite important. And basically, here's the main object and the offset of the waves. That's why you come back to here. So if you have too little, the waves don't make contact with the interior wall. 6 seems to be about right. So there's a lot of other effects in this software. Just it's really, really amazing, easy to run. And it's as simple as coming over here and you can name your G-code file and download it. And that's it, up to the machine. You want to show the machine now?
Yes, so now let's switch back to our front. So after we've generated this file on through Potterware, you just download the G-code simply, and through the print interface, we can start and run files. So we're actually going to, first thing we need to do is we actually need to put the extruder onto our printer here. So we're going to run our print start location program, and that will bring the extruder arm down to where it needs to be mounted on the extruder.
Today we're using pre-prepared base, and the base is essentially, we like to work on a piece of drywall. Then we've rolled out a small slab. You can also print the bottom, but this seems to be a little bit easier for demo.
Okay, so let's get the extruder onto the printer. Slash that closed. And so now the printer is at its starting coordinates. So Z height is at 0 right now. So we can adjust the extruder height in the print in its bracket here. And we have a clay slab flat, and we're going to bring the nozzle tip basically just touching the clay slab just barely, or maybe even a little bit higher.
Are we on this screen?
Are
we on this screen or this screen?
It's the whole shot here. Yeah, they can't see this right now.
Okay.
Let's take this. And sneak this under. Yeah, there we go. This was just to keep the moisture in. So now it's about 1 or 2 millimeters just from touching the clay. And here in the interface too, you can also do a little baby Z stepping, so you can increase and lower it as well. So now the print's running, and machine's going to home itself, and then it will start the print. At the start of our prints, we're going to, in the interface, just slightly increase the extrusion rate just a little bit, just to make sure the extruder's primed and there's some good pressure in here. And then we'll back the extrusion off a bit, and then we can adjust the speed. Speed down. Go. And now I'm just inspecting the clay flow rate right now. We want enough extrusion to do loops, so With Potterware, it's very, very good at doing loops and all kinds of designs on the pot. And in order to do the loops, we need a little bit more extrusion. So when it loops out like this, like whoop, that the extrusion rate is enough to keep it as one solid continuous stream. The extrusion rate is pretty good. We can increase the speed a bit now with the extrusion rate good. I'll wait for the first loop pattern. See, there's the first.
This is a 8mm nozzle pushing out quite a bit of clay.
Yeah, so this is using a lot of clay, where this is an 8mm nozzle, and we're going to ramp the speed up now. That looks like a pretty good amount, so let's increase the speed here. And let's not push it all the way to the maximum, but just a bit to get it rolling. So and so one of the, you could say, we wouldn't want to go too fast, because eventually, you know, the vibration changes and everything. And if we were doing a very, very tall and narrow object, you know, the whole clay piece could move back and forth, like almost like it's in an earthquake. So at least when we get a bit higher, we'll want to slow the speed down a bit. And, you know, this is, for an 8mm nozzle, this is extremely fast. And we could go even faster, but to preserve the quality of the print in general, we'll probably slow the speed back down just a bit. So, you know, if we're making a beautiful art piece, you know, we'd want it to look as clean as it can. But if you want to get a bunch of prints done really fast, and, you know, you can even put on a smaller nozzle and go even faster. I think with 5mm nozzles, you can get to like 250 millimeters per second print speed, which is insane for like a 5mm nozzle. But this is probably running at about 50 millimeters per second right now, but it's an 8mm nozzle, so we can't go too much faster than this.
We can go all the way up to 12 mil nozzles, and even larger custom nozzles on request.
Just dropping the speed down just a little bit so the print gets preserved. And maybe that camera's been shaking a little bit too much with those speeds. Oh no, it has some motion stabilizing, so. So this is our version 9 Pro. So this is kind of our
10.
Or 10, sorry, apologize. We're no longer produce version 9. This is our version 10 Pro. And it's pretty much, at least what I consider our best printer. You know, we have a version 10 Micro, Pro, Super, and XL. And this is our Pro version, which uses what we call our all Pro motors, or closed loop hybrid stepper motors. And this guy over here is our Scar printer. So this guy uses the same motors as our Pro.
It's not in the frame. It's being blocked by the small camera.
No, it's totally in the frame.
Is it?
Yeah.
Okay.
Yeah. So this is our Scar printer, and uses basically the same motors as our Pro. A couple of them are stronger, like the extruder motor has a much larger tube, so the motor on this guy is much stronger than our Pro's motors, but it's just a more beefier version of it. And with our Scara printer, it has a huge print area. It has 360 degree rotation, and this is just our normal cardinal axis printer. If I remember, what's the print area? Like 20 by 20 inches or something like that?
You should know this by heart, man.
Oh well, I don't remember 500 different values.
We should describe the different print bed on each machine. So the Micro has what, 10 by 10?
The Micro, I know that. It's
by 12 inches?
10 inch by 10 inch by 12.
Okay.
And then...
Are you pulling it up?
Yeah.
Yeah, we should know this by memory.
Yeah, well... There we go. And then the 10 Pro, it's 16 inch by 16 inch by 20. Our 10 Super, it's the same, but with the 10 Super, it actually uses this extruder, and this extruder is much wider. So just picture this boy on here. This is 2 liters, and that is 3.6 liters. But with the 10 Super, the whole machine has a lot more reinforcement to, you know, to handle almost 2 more liters of clay. And the XL is 19 inch by 19 inch by 28 inch. So it has a massive print area. And that, again, that uses like the same extruder as the Super. So you can do huge pieces like this big with that printer. And then our Scara, which is this lovely guy dancing here, has a 72-inch diameter print area on our default Scara model. And
up to 69 custom. We can go 69 inches on the Z.
On the Z, well, yeah, 68.
Yeah.
Or, yeah, 68 on that. And then normally it's just 42 inches high. But we also do some custom stuff with it. You know, sometimes we made one that goes all the way to the ceiling.
We also have Scar printers for industrial applications. So we're getting larger. So we're able to print small habitat and concrete structures. And we have a couple of new pumps coming onto the website. We also have a new track system for the Scara. So we're getting to the point where we can increase the work envelope to, on the X, can be quite large, 30, 40 feet. And the diameter can be close to 15 feet. So we're able to start producing large structures. Talk about the interface a little bit.
Yeah, I was just thinking about that. We're 68% done, so I'm gonna head back over to our computer and I'll show you the interface and some of the controls. So here's our Duet web interface. It's called Duet. That's the control board in there, but you could just say it's our 3D Potter
Doing
interface.
okay?
And here we have full control over our print. So this is our print. We didn't name the file. It's just a giant name of .g code, and we're 75% complete. So here we have speed and extrusion control factors that we can change live. And when you increase the speed, the print bed moves faster, and it also automatically increases the speed of the extruder to match it. So we have our extrusion rate set right now at 140% for this print. But increasing the speed, we no longer have to touch this extrusion slider. This is what I was talking about at the start of the print. I ran it at like 160 just for the very start, and then I brought it back down to 140 so it can do the loops well. Here's the little baby stepping controls. So if you quickly need to increase or decrease the height of the extruder manually during the print, you can just use these controls. And here's on the dashboard, we have we know what position it's in on the X, Y, and Z coordinates, updated in real time. And home all controls. So when a print's done, you can move the print bed around. Same thing for the Scara. These machine movement controls are very useful for the Scara printer. So you can move around and see where you want to print, or do multiple object printings and things like that. Your jobs, you can sort the G-code files. So these are the files you upload to the printer to run files. So, you have file names here. You can sort by file name or last modified date. So the last file you upload to the printer, you can just click that and run it. And you also have, full administrative access to the printer through this interface. So if you want to change config files, how the machine homes and things like that, you have very huge, not admin access, but like root access to the whole printer. You can change anything you want to. And even, things like how fast the rails move when you're homing. Right now it's set to 5,000. That's, in 3D printing terms, F5000 is a slow to medium speed, so that's fine. And the print should be almost done. So back to status, so 94. So let's go back to the front and watch the print end. Sorry about the vibration on this camera. This is first time trying this stream, so we will see if we can improve this in the future in future streams. And there we go. And now this is as if a pottery piece has, just come off of a potter's wheel. So if you're a professional potter and you're tuning into our stream, welcome and thank you. And now we would put this on a drying rack. You'd let it dry for the correct amount of time for that clay, the stoneware. We're in Florida, so we'd let this sit for at least a week and let it dry very, very slowly, and either in a special drying rack that loses humidity slowly, or we could do it the cheap way and just put a plastic bag over this and then take it off, turn it inside out every day, and that'll very, very slowly reduce the moisture content of the clay. It'll shrink about 10% in size, or roughly maybe 5, 10, maybe 15% with some extreme clays. And then you just fire it normally, fire it in a kiln. This is fired at cone 5, I believe. And then, you can glaze it, paint it, glaze dip it, any other designs in the shop. Yeah, sure. I'm going to check all the questions coming in. Yes, that's a good question about retraction. So yes, this is a Model 10 Pro, and so for retracting with our printer, it is very possible now with our 10 Pro series. So in fact, I think it's not possible. It's 100% capable of it. The only thing is this is a lot of clay in this tube here, and so we estimate that the pressure in the tube is could get upwards of 30 or 40 or 50 psi. So that's a lot of pressure. So this piston actually has to retract very quickly to retract, so clay stops coming out. We'll show that in the next print. We'll do a pause resume, which is a retraction, and there's only a little bit of a restart period for it to reprime, and then it resumes just fine. But now let's take this off the print bed and let's put on the next piece.
Okay, I just created another file in Potterware.
So just remove these 2 clamps here, and we would just take this over to a drying rack. Okay. That looks about centered. And so now we don't have to readjust the extruder height. This clay slab and this drywall piece, you can also use wood or any other piece or another bat to put the clay slab on. We just prefer drywall. And this is already level to the clay slab, so we don't even have to adjust the extruder.
You see the question?
I'm going to bring the speed down for the start of the print. This might be in the way. Yeah.
Which ones are more recent on the bottom? I think he answered the retract one.
Just digging into the clay slab a little bit there. That's A-okay.
Okay, we have a question. Does the pressure in the tube vary as the tube starts to become half full or quarter? No. That's where our design is really superior, because you have the exact same pressure throughout the entire process.
Yeah, it's only the startup procedure. Like I said, it's a little bit cheaty, but slicing software actually makes this a big thing of increased flow rate for the first layer or the first prime layer. That's a big thing in 3D printing in general. And so here I'm just kind of doing it manually because we generated this with Potterware. And Potterware, you can do skirt lines. So it does the priming of building up pressure by doing outlines around the outside, and then it moves into the middle of the piece and then goes. Here, I was just doing it manually a little bit. And the pressure's constant. So now that we're at pressure, there's no variation in pressure. It's just a constant stream of you can look at this and call it an overgrown syringe. And this is the plunger, the piston, and it's just moving down at a solid, constant rate of moving down. The only time there'd be pressure changes is when you're actually increasing speeds
or retract
or retracting.
And that's why our retraction works so well, that we can unload the screw and the piston so fast that you can stop the flow, start it.
Which we're going to do right now.
Are we?
Yes, we are.
Let me answer this question here. Does the paper come off the drywall? No, I haven't had any problems with the drywall. We don't reuse it too many times. I think you can, but the advantage of the drywall is the gypsum pulls some of the moisture off of the bottom. So tomorrow it'll come off the drywall really super easy. Just comes right off.
Yeah, and this is our other preferred printing material. So we're just using drywall here. This is just 1/8 inch, this is 1/8 inch plywood, and we at least I think this is a great printing surface. If you have a clay slab on here, you just slap it on and print just like we are now. So it doesn't have to be drywall. It can even be another one of our own bats, your own bat, and we just have 2 clamps on here, so we can quickly, continuously make pots constantly.
Okay, another question. Hi, Romania. This is a 10 Pro, right?
Yes, 10 Pro.
Yeah, this model is a 10 Pro.
Okay, we're going to actually do the little retraction function. So this file doesn't have retraction in it, but there's a pause function on the interface. So in the job control sections, there's pause and resume, and so we're going to push that in just a moment.
Hi, Alana from Brazil. Do you have any questions?
So the print's actually paused, and this coordinate right here is saved in the buffer memory of the printer, and it doesn't have power loss protection yet. But so this coordinate right now is just saved as temporary, and all I'm doing here is I'm just taking off a little bit of excess that was just left behind, and then we can resume the print. And what will happen here is it will go back down to its last saved coordinate. It'll reprime, and then the print will continue.
I just hit that. Yep.
Okay. Do you remove the paper of the drill?
Got that.
Can you print?
So here's the reprime.
That's my next one.
Okay, good.
Where I move my phone again.
Maybe it needs a bit more reprime because we have an 8mm nozzle. You can see it on this camera here. It didn't quite just get enough, but this pause and retract script was tuned for a 5mm nozzle. So it doesn't need to reprime as much. So in an 8mm nozzle, you would have to actually up that a little bit manually. And that's what I was talking about earlier. You have full admin access to this machine. That would be in the system settings where you can mess with config and home all files. One of the files is pause, and you can increase how much it reprimes there depending on what kind of nozzle you have.
Okay, I have a question. How small can you go?
The smallest we've done in the show.
I'm going to answer it.
Okay.
We can go down to half a millimeter, but it's not practical.
Yeah.
We make 1mm nozzles. We have a customer that wants a 1.5, but typically it's not practical for most of the clays we use because it takes too much pressure to push it out of such a small orifice. So in reality, 2mm is about minimum, don't you think?
Yeah. I mean, if I was in a school environment, I'd definitely not want to go smaller than 3. And even though if you had a lot of a huge group activity of some kind or a lot of students, 3mm nozzle will preserve the amount of clay because smaller nozzle mean less clay. But if you get smaller than that, you can get very tall and narrow walls that fall over very easy because this is not plastic 3D printing. This is clay. So, it's all, it's very malleable, even though this has been sitting here on this bat for, minutes now. So wall width, which should be tied to nozzle size, greatly matters for your piece. And there's actually a sweet spot, 5 to 8mm, that range is where you can get the absolute biggest pieces. Because if you do something like, I'm just making this up, like a 20mm wall, once you get up just a couple inches, there's so much weight that it will collapse in on itself. But with a smaller nozzle, like an 8mm nozzle, you could actually get very, very high.
48 inches, 50 inches, which nobody else can do because our clay mixture is really quite tough.
Yeah, this is not slip. Let me just try and not ruin the whole piece. Thank you. So, no, this is not slip. This is full body clay. Water content is comparable to bag clay. We add just a little bit. So a prepared bag of clay, we add 15 ounces of water or even less. And then that goes straight in the tube.
Okay. I have a question. I have an earlier model extruder, and they want to know if the retraction, if the hardware has changed. He's talking about retraction, and the answer is yes.
So there's a lot of changes. I'm just going to say if you have a version 9, say the 9 Pro or higher, retraction would be possible with some tweaking of the config, and documentation's out there.
But not with stepper motors.
Stepper motors, no.
They're too slow.
We do not. We would not say you could use our micro printer, which uses very small stepper motors compared to our Pro motors.
Speed it up.
Should not. It could do retraction if the clay was soft enough, but
it's not practical.
No. But if you're asking about the actual ability of a 9 Pro versus 10 Pro doing retraction, a 9 Pro should be able to handle retraction. Yes.
Hello to South Africa. It's cool seeing all the people all over. I have a customer in the UK talking about small nozzles, and he prints with porcelain. In porcelain, you have a little bit better ability to utilize a small nozzle. So he's down to 2, and with some really remarkable results. Another question about aluminum material. Again, it depends on the type of material, the texture, but 2 or 1.5 is minimum. We also have a secondary company, which is Metallic 3D, and for aluminum, and also we can print metal materials, stainless steel, copper, aluminum. We have the sister company that actually makes machines for printing metal and alumina. So you can check that out on the website, Metallic 3D. Yeah, sure.
So this is what Dan was just talking about. So these are some of our, let me maybe post it on this camera here. These are some of our metal pieces. They're all going in this camera of what
it's 316 stainless.
Yeah, 316 stainless of our metallic printers I've been going on. We're still in a very big testing phase, fine-tuning stage. So, but we do have that live on Metallic 3D as fully working. So,
okay, another question. Can we put holes in objects? Yes and no. It depends on the size of the hole. If you're talking about printing gaps, I don't think I have one here, but like a cup handle, you can print. Speed it up. Let's crank it up.
Okay.
You can print a cup handle, and you can actually put support in the handle itself. And as soon as the object goes leather hard, you can cut it out. So I hope that answers your question.
Oh, there was another question. How much noise does one of these machines make in comparison to an FDM printer with a silent board?
Absolutely nothing.
Yeah.
You can, I mean, there's no noise coming from this machine. You can't hear the fan, and the motors are super quiet.
Yeah, so the loudest motor part is actually this motor, the extruder motor. And
Only when you're cranked up
Yeah.
really fast.
yeah, you know, if our version 10 series, it's actually like you don't even hear the actual printer. That's only if you're running fast prints. If you're running a very modest speed, like 30, 20 millimeters per second, which is what we recommend to start with, you don't even hear it. Like it's quieter than a normal computer for certain. You know, a normal computer that has cooling fans on it and such.
Okay, what type of clay are we using? Basically, Laguna bag clay. This is B mix, and the number is WC401. WC401. And like Dennis was mentioning, we put about 10 to 15 ounces of water in the clay just to bring up the moisture content, which you actually need for interlayer adhesion. So if the clay is too dry, you're not going to get proper adhesion.
Yeah, there's if you can, I'm not sure if this camera can quite show it, but I know, I don't know if there is a proper term, the mushing factor of how much one layer is pressing into another here.
That point is actually it's very important.
Yeah.
So if you don't have enough pressure or your layers are too high, the clay will basically just stack on top of each other, and you're not going to get a good adhesion. So if we had a close-up, Dennis, I mean, you can actually see it.
Yeah, yeah. So, you know, there's a couple of the other, you know, previous pieces. This one shows it pretty good. So the amount of how much one layer got pushed into another here. And it is sort of a sweet spot, but the default settings of what we provide we provide Simplify 3D and Cura slicing profiles. And Potterware actually is really high on extrusion, which is good for interlayer cohesion. So at least, you know, if you could try and get it smaller to preserve clay or even do crazy fast prints and stuff like that, but our default settings at least kind of have a very good adhesion factor, I would say, or mush factor.
Okay, first person that noticed the ducks, I'm really impressed. So we received an order from a country we won't mention, and it was full of these small ducks, and they seem to be just all over the place.
Yeah, we had a large order of parts, and we bought so many, they gave us a whole case of these little ducks.
Okay, Nathan, is there any reason a recycled clay body should not be used? It's an excellent question.
Yes.
So we can recycle these as soon as we're done here. Actually, we probably will.
Yeah.
And
Let me get a chip.
what are you doing?
I'm getting a chip to show them.
Oh, no.
Yeah,
Okay,
it's a good
so
question.
to answer the question, yes, it's super easy to recycle, but you have to be really careful to keep it incredibly clean, because as soon as you get some debris,
I'll show it on both cameras.
yeah, even if it's clay, if it's hard clay debris, what you're going to get is nozzle blockages, and there's nothing worse than getting 3/4 away through your object and then it blocks up. So if you can keep it clean, yes, you can continue to recycle.
Yeah, so this is a dried chip of clay, and as you can see, you know, there's clay here, and if we have small smears of it, this will dry pretty quickly because it's just a small thin layer, and at least for stoneware.
Yeah, but here's the problem. Like in our pug mill, we have a Peter Pugger.
Yeah.
And you'll get some hard debris around the lid, and that hard clay goes down into the clay body, and for some reason, it doesn't reconstitute. It'll actually come out hard.
Yeah, so that little chip I showed you, for this clay, which is our stoneware, it doesn't reconstitute those little chips automatically on its own. they'll stay dry as a little chip, even running through our pug mill for 30 minutes.
Yeah, I don't have the answer to that, but
It's
if you can, to answer the question, if you can keep it clean, you can continually just
yeah,
totally recycle, which is really nice in a school environment.
and
You know, so the kids can make the object, recycle it, going over and over again.
yeah, in some school environments that I've been to, they have a whole section dedicated, to that. I've seen special grinders machines and powderizing machines that will take those clay chips and like re-powderize them so then they can be properly reconstituted.
So before it really dries, before we put it on the shelf, I typically just cut the base off like this and reuse it.
Okay, question was we had was fried clay with a 5 mil nozzle at 2.5 millimeter layer height, and we had a lot of trouble with the clay pulling away from the previous layer at slow speed. So yes,
The layer height's too high.
layer height's way too high. So
Down around 1.5 is a typical 1.7 maybe for a 5 mil layer height.
what'd you do?
This is 2.2.
2.2?
Yeah, and we could do much more. We could probably go to almost 3 with a 8 millimeter nozzle.
Yeah, with 2.2 layer height, this is with an 8 millimeter nozzle at 2. So each layer tongue is 2.2 millimeters up. So with a 5 millimeter nozzle, that will be more difficult for the same layer height. There should be a direct correlation there. If your nozzle is bigger, you can do a bigger layer height. And I personally recommend with a 5 millimeter nozzle, which is what our softwares are tuned for, to start at 1.5 millimeters. And that's to start to learn our machines with a slow speed of around 25 millimeters per second.
Okay, you're answering Daniel. Also, Daniel, yes, if the clay body is too dry, like I mentioned a moment ago, you're not going to get good interlayer adhesion. So, those are the two factors.
Yeah.
If it's dry and layer height, and you need to be pushing the layers into each other. So if you look as it comes around, you can see the layer underneath is dishing down a bit. All right, what do you want to do next?
This is enough clay for our test base.
Is it in here?
Yeah.
Okay.
Yeah. So I'll actually print that directly on the bat then.
Yeah, here, let's demonstrate. Here, back up a little bit. Just to show you that it's not slip. I mean,
oh, I'm going to do a thing.
No.
Yeah.
Just to show you that it's not slip and really has a lot of body. I mean, I'm totally manhandling this. So,
yeah.
I mean,
yeah, so that's actually something we haven't talked about yet. So pots like this, it's as if it came off a pottery wheel.
Yeah, some people actually do manipulation
So
afterwards, and I've seen some very interesting results. But just to show you that this is totally not slip type play.
yeah, and then that we can absolutely reuse because nothing's really got dry chips of clay here. So that we would actually just throw right back in our pug mill right away. Let's go back to the interface real quick so you can see how we start a print from the interface, like the whole experience of it.
Tell Dennis.
Okay, so we're back here at the interface here, and let's go to the computer screen. So then we're going to click on jobs and run our test phase file, and we're going to run quickly back over to the printer. We'll reset the speed and extrusion factors, and we'll shift back to shop front. So now the extrusion height is incorrect because now we no longer have a clay bat, and I'm going to actually remove this. So the extruder is going to be way up in the air. So I'm going to adjust this live and bring this down. And we're going to up the extrude rate to get it rolling. Here we go. So it just did 2 outlines of our test vase file, and now we're actually printing the actual vase now. Just clean the nozzle up here a little bit.
That's a large nozzle to be doing that.
Yeah, so this test vase is actually designed for a 5mm nozzle. And so we're actually have the incorrect nozzle size for the G-code file that I selected to print. And so you can still do that, but you will really have to fine tune the extrusion control factors that I set back to 0. I now just increase that back up. Extrusion factor is actually at 250% now.
Too much flow.
And it's too much. So I'll bring that maybe down to 220. Still a little high, maybe down to 200. Still a bit, maybe 190. That's pretty good. And so, you know, this is designed with 5mm walls in mind.
Dennis, I've got 2 comments here. It says that you should let your boss talk more. What's up with that?
I don't see those comments. Thank you for employing me here at this lovely company called 3D Potter.
You do realize that your employment is contingent on the quality of this video, right?
Oh, well, we better get up to 100 viewers real quick.
What do we have?
26.
Crank it up. Show them
Okay.
how fast.
Yeah. Okay.
Maximum.
We're gonna push it. So, disclaimer:
This is ridiculous.
the motor could over torque and stop, or the pot's gonna fall over, something. But let's push it.
Just do it.
So right now with 8mm nozzle again. Okay. That was 30mm per second.
Cut the flow down. Wow.
Here's 45. Yeah, I'll cut it down a little bit. So. This is 60mm per second, which is like standard 3D plastic printing speed.
I don't think any other printer can do this type of performance.
This is 75.
That's good.
Let's get up to 90. So this is 90mm per second print speed. We have some noise canceling software, so you may not be able to hear, and probably the phone is vibrating out of control. Yes, it is. So sorry about that shot. I'll hold it to kind of stabilize it a little bit. But yeah, 90mm per second speed with 8mm nozzle. And this camera is directly mounted to the bat, so there's some intense vibrations when you really get up to speed. In fact, I'm just gonna free cam this and hold it so it doesn't jiggle everywhere.
Yeah, it's actually printing so fast, it's not practical. This is just for a demonstration.
Yeah.
The clay body will start to vibrate after a while. Take this off. Oh, sorry.
There we go. It'd be cool. Print's almost over. Never mind. I was going to say to full screen this, but I don't have controls here to do that.
I have a question. Would it be feasible to upgrade our older model? We do have an upgrade kit to take, what, the 7?
7 or 8
7
to
or 8, yes.
version 9. So you
Right.
can upgrade to a version 9, which uses the same electronics as our version 10. So it's a pretty substantial upgrade. It gives you a lot more control of the machine, of just in general of everything. But you cannot upgrade from 9 to 10. 9 to 10, it had a full machine redesign and too many parts have changed.
Right, or the really old Delta machines.
Yeah,
it's
the Delta
not
machine.
possible.
Yeah, our version 2 printers can't be upgraded at all, unfortunately. But if you have a version 7 or 8, you can absolutely bring that to version 9, which uses the same electronics as our version 10. I'm actually going to turn this camera off, so I'm just going to go put this down and shut that off.
Dennis, they want the link for Metallic 3D.
Metallic 3D, sure, I'll put that in the
Yeah,
chat.
we'll put the link to Metallic 3D up. Okay, any other questions? I think this was quite successful for our first live stream.
There's a couple links to 3D Potter and our Metallic 3D website. Anything else we're covering? Yeah. This is kind of the whole stream. That was the basic operation of everything, you know, in general, of putting a tube on, our interface controls, and a little introduction to Potterware.
That's it. I think it was pretty good for the first
Yeah.
live stream. So let me know if you want us to do this on a regular basis. We're thinking of doing it. And comment on the time also.
Yeah, this was about, yeah. You know, if you're all over the world, you know, we can change the time. We just chose noon Eastern Standard Time. So pretty much people in Europe and Africa can still be awake, and the West Coast of the United States can be awake too. So, okay. Thank you very much, everyone, for tuning in.
Thank you.
We're going to go end the stream. Oh, a couple more questions. When is the next live stream? We plan to do it bi-weekly. So, you know, 2 weeks from now. How long can clay be left in the extruder? That can be, if it's sealed, months at a time. But once an extruder has been opened, only about 1 month, I would say, would be the maximum.
We should have introduced the whole.
And then,
1 month. 1 month is ideal. However, I've used it up to 3 months.
yeah. If it's sealed, prepared, which we'll cover in another stream, can't cover everything in one stream. But you can definitely let it go months on end if it's properly sealed. But yeah, so maybe we'll stream every week. Probably not next week, but next Friday after the coming Friday. So by every 2 weeks, we plan to do it. Okay, see you guys. Wait. Okay. Back out to the front. Okay, maybe we're not ending the stream quite yet. Oh my gosh. I don't know.
Okay, one of our workers suggested that we need to introduce the whole crew. So
Oh my gosh.
everybody come here.
Yeah.
Dennis,
Come on.
Beth.
Come on. You don't want to get over here? Come on over here. So this is pretty much almost all of our staff. Almost. But a couple people aren't here today.
Oh,
but
yeah, we have a couple of other people, but
yeah. Yeah. Come on. Swoosh. Yeah.
Go
So I'm Dennis. I'm our tech support guy. I handle all of our tech support and machine testing. And yeah.
Child support, I guess.
Yeah.
I'm Pete. I built printers.
See here?
And I'm Ryan. I'm an assembly tech here.
Yeah, but
And
we're a pretty small
I'm,
team.
I'm Danny. I don't really know what I do here sometimes.
Okay. Thanks for tuning in, guys. I'll see you next week.